So, what is sequence to sequence model? Till now, we have covered the basics of natural language processing, which we use in deep learning. Now, let's try and understand what is sequence to sequence model. So, in order to solve complex tasks like language translation, creating a chatbot, text summarization, question answer system, sequence to sequence model works very well, or it has been seen in various fields where sequence to sequence model works best for this. Okay, so encoder decoder architecture is one of the most common sequence to sequence model architecture available in the market. So there is one encoder, so it encodes the output and gives a context vector, and this will go to decoder, and then decoder will give you the output. So this is the basic structure of how encoder and decoder works. Okay, so now let's discuss them briefly. So before we go and discuss encoder and decoder, let's discuss some of the real life examples of sequence to sequence model. Some of the examples which we use in our day-to-day life is Google Translation, Google Assistant, Siri, Grammarly. Then we use Google's Smart Compose. We use Android Smart Keys. We also use Alexa. Okay, these are some of the sequence to sequence based models use case which we use in our day-to-day life. Now let's discuss how encoder decoder model works. So this is the basic structure of encoder decoder model. So encoder decoder model both uses RNN. Okay, so it can be LSTM or it can be GRU. Okay, so these can be the RNN models which we can use in decoder encoder, but we need to keep in mind that if we are using LSTM, then we cannot use GRU here. Okay, we will use only LSTM. Okay, or if we are using GRU, then we will not be using LSTM. Okay, we will be using GRU. Okay, so now let's try and understand how this encoder decoder works. Okay, so we can have a box something like that. Let's call it encoder denoted by E. Okay, and we have a decoder, the same as shown in the picture, that is decoder denoted by D, and it has few RNN states, and similarly this has few states, this. Okay, now suppose I want to feed a input. Okay, let's write how are you. Okay, and this gives you a output, I am good. Okay, so First, this how will go. Okay, so I'll just mark it 1, this as 2, this as 3. Okay, so the moment this will, how will go to this, okay, this 1 will go, then this H1 is generated, that is hidden state 1. Okay, so then this will go to the model, okay, as shown in the picture. Then similarly 2 will go, okay, then this 2 will go, okay, and it will generate H, and this will generate H2, then this H2 will go, and then this 3 will go, okay, and this will generate H3, okay, H3, and this H3 will be your context vector, we can say, or we can say encoder vector, okay, as shown it here, okay, and this will go to this, okay. So the moment it will go here, it will generate I, okay, then this will go to the next context, it will generate M, then this will go to the next context and it will generate good, okay. So if we see closely in this diagram, what we can see that in the second box or the decoder, we have the outputs and we have the next hidden state. But in this, if we see closely in this encoder, we don't have the output from this RNN. So the RNN architecture of encoder is such that they don't produce the output, okay, and we don't or we can say we don't store the output here, okay. Instead of that, we provided the hidden state, okay. So this is the basic structure of how encoder decoder works, okay. So now let's move on to our next slide. So encoder decoder using teacher forcing. So what happens that when we train our model, okay, so sometimes this happens that encoder decoder model takes very long time to process, okay. So encoder decoder model are known for taking very longer period of time to train, and some of the time they overfit itself, okay. So in order to tackle that, we use the teacher forcing. So how teacher forcing works that when this hidden state 3, let's say H3, goes to this, okay, to this encoder vector, okay, this encoder vector, let's suppose that this is H3, it goes there Y1. Similarly, there is one output. This is your decoder input, okay. So this is your encoder input. We do not directly give the X1, we do the embeddings, okay. So be it word to word embedding, like be it word to vec, be it character based embedding, be it one hot encoding embedding, anything, okay, bag of words embedding. But we do provide this encoding to this X1, X2 and X3 are nothing but the input vectors. Okay, so this goes there. Similarly, this decoding input is nothing but the input vector for the correct output. Okay, so this goes there. Okay, so the moment it goes there, and the moment it predicts, let's suppose that it predicts y11. Okay, and then it checks with this decoded input that whether the output which it is generating is correct or not. Okay, so our correct output is y1. Okay, so the model will penalize itself. Okay, the optimization technique will start working, and it will penalize the model. It will do the uh, like update the weights of the RNN model, and then it will refit itself so that it can generate y1. Okay, so this way we get the better result by applying teacher forcing in encoder decoder model, and it also stops model to getting overfit, as well as it helps us in it reduces the time taken to train the model. Okay, so let me erase this. Now let's move on to next slide. So what are the drawbacks of encoder decoder model? So it has been seen that the encoder decoder models have limited memory. Okay, so since we are using LSTM, okay, so it can perform well with longer text, but this cannot work well if we are passing a entire like sentence, or a sentence is containing 100 lines of text. Okay, in such situations, encoder and decoder model not perform well. Okay. Similarly, model does not perform well when the length of the string is greater than 10. Okay. So with the help of Blue score, in various researchers researched, and they found out that with increase in word length, the blue score started decreasing. Okay, so blue score is the parameter with which we can judge the performance of any encoder decoder based model for machine translation. So this has been seen that with this it starts reducing. The blue score starts decreasing. So in various researchers found out, after performing various research, they found out that if the word length is greater than 10 or is 10, okay, it does not perform well. This is not a thumb rule, but this has been seen in various situations. This can be opposite of that for some of the cases when our data is different. Okay, since we know that machine learning or deep learning model works on data. Okay, if your data is correct, model will perform well. If your data is not correct, model won't be able to perform well, whatever technique we can try. Okay, so this depends upon the type of data as well, or the data and the frequency of the words. But it also has been seen that with a longer string, a model does not perform well. Okay. we can remove those tokens, and then we can retrain the model, and that model will outperform this existing model, and then we can do some of the architectural changes, and let's say we can use attention into that, we can use beam search into that. So we can do various kind of a thing in this model and get a good result for that. But for this use case, our intention was to just build a sequence to sequence basic model and try and see how the results are coming for a machine translation model. Okay. Now we have concluded our syllabus, or we have reached to the end of this tutorial. So now let's recapitulate whatever we discussed. So in this tutorial, we discussed what is machine translation. Okay. Then we saw some of the examples of machine translation, like Google Translation, Siri, and things like that. Then we discussed what is SMT, or statistical machine translation, and how it works, and when it works well and when it fails. Then we also discussed what is neural machine translation. We discussed some of the NLP concepts. Okay, like what is word to vec. Okay, what is of words. Okay, how RNN came into the picture. Then we also discussed what is LSTM. Okay, long short term memory. Then we discussed gated recurrent neural, that is GRU. We discussed what is gradient explosion in RNN, okay, and how LSTM and GRU prevent it. Okay, we discussed these things also. Then we discussed what is encoder decoder based models. Okay, what is teacher forcing in encoder decoder, and how we implement teacher forcing. Then we implemented a encoder decoder based model in Python with teacher forcing, okay, with the help of Keras, and we built a English to French translation model. Okay, so that's it from this video. I hope you enjoyed this session, and you got a clear picture about what is machine translation, how machine translation works, what is encoder decoder based model, how word to vec works, and things like that. Okay, so till then, keep learning, keep growing.